All right, let's dive into one of the most powerful concepts in Python, loops. Seriously, if you want to make your code do the heavy lifting for you, this is it. Think of loops as the autopilot for your code, letting you handle massive, repetitive tasks with just a few elegant lines.
Let's start with a really basic question. Why would you ever want to write the same line of code over and over again? The short answer is you don't. If you ever find yourself copying and pasting, that's a huge red flag that there's a much better way. And that better way is exactly what loops are for.
So just look at the difference here. On the left, that's code without loops. It's just a long, boring straight line where you're repeating yourself. But on the right, that's the loop. It's an efficient, elegant cycle. You write the logic just one time, set it to run, and it doesn't care if it has to run 10 times or 10,000 times. It just works.
So what is a loop, officially? It's what we call a control flow tool. All that means is it's a way to control the path your program takes. It just repeats a chunk of code again and again until some condition you set is no longer true. It's that simple, but oh, is it powerful.
Okay, in Python, you've basically got two main flavors of loops. We're going to start with the most common one, the absolute workhorse, the for loop. This is your go-to tool whenever you're working with a known sequence of items.
Think of it like this. You've got a shopping list, right? A for loop is perfect for that. You know exactly what's on the list and you want to do something for each item. Grab it off the shelf. You're basically telling Python, for every single item in this group, I want you to perform this action.
And the syntax is just beautiful. It's so readable. You start with the keyword for, then you make up a temporary variable name. A good habit is to use the singular version, like item. Then you have the keyword in. And finally, the collection you're looping over, usually with a plural name. So it literally reads like a sentence, for item in items.
And the great thing is you can loop over all sorts of sequences. You can go through a list of names, you can iterate over every single letter in a string, you can work with tuples. But one of the most useful tools you'll use with a for loop, by far, is the range function.
Ranging is your best friend when you just need to do something a specific number of times. If you say range 5, Python generates the numbers 0 through 4. Remember, it always stops just before the number you give it. You can also give it a starting number, like range 1-6 to get 1 through 5. And you can even add a step to skip numbers, like this last example to get all the even numbers up to 10. Super handy.
Okay, for loops are fantastic, but what if you don't know how many times you need to loop? What if you just need to keep going until, say, a user types quit? That's where the other type of loop comes in, the while loop. A while loop's logic is all about a condition. It's not about working through a list. It's more like a gatekeeper. Before every single repetition, it checks a condition. As long as that condition is true, the loop keeps running. The very moment it becomes false, the loop stops cold.
Now, this is absolutely critical. To use a while loop safely, you need these three parts. If you don't, you risk creating an infinite loop. And trust me, you do not want that. So first, you initialize a counter variable before the loop. Second, you use that variable in your condition. And third, and this is the part people forget, you have to update that variable inside the loop. If you don't, that condition will be true forever.
So, which one should you choose? It's actually pretty simple. Use a for loop when you have a definite set of items to go through, a list, a string, a range. Use a while loop when you're just waiting for some condition to change, like waiting for a user to enter correct input. Just remember, for loops are generally safer, while while loops offer more dynamic control, but come with that risk of running forever if you're not careful.
Now let's get into the really cool stuff. Python doesn't just give you these loops, it gives you special commands to fine-tune exactly how they run. This gives you an incredible amount of precision.
First up is break. I want you to think of this as the big red emergency stop button. The moment your code hits a break statement, the loop is over, instantly. It doesn't finish the current cycle, it doesn't move on, it just bails, right then and there.
Next, you've got continue. This isn't the emergency stop, it's more like the skip track button. When your code hits continue, it immediately abandons the current iteration and jumps straight to the top of the next one. It's perfect for when you find an item you just want to ignore, but you want to keep the loop going for everything else.
This table lays it out perfectly. You use break for the really serious stuff. You're scanning files for a virus, you find one, boom, you break. You continue for minor problems, like a single bad row in a huge data file. Just skip it and move on. And then there's the else clause. It's a little weird, but it's awesome. It's like a success message that only runs if the loop finished its entire job without ever being interrupted by a break. It's a great way to confirm that your search completed and found nothing wrong.
So, we've gone through all the theory, but why does any of this actually matter? Well, let's talk about the payoff. Let's see how loops are used in the real world to do some truly incredible things.
I mean, the possibilities are practically endless. You can write a for loop that renames thousands of messy files in seconds. You can calculate totals and averages from huge lists of data. You could move hundreds of database tables. You can use a while loop to keep asking a user for input until it's valid. This is where automation really comes alive. It's how you go from writing simple scripts to building powerful applications.
I absolutely love this quote because it just nails it. A few simple, well-written lines of code inside a loop can do the work that might take a person hours, maybe even days, of mind-numbing manual labor. That is the fundamental power of programming. So you see, loops aren't just a feature of Python. They're a mindset. It's about training your brain to spot repetition and then thinking, how can I automate that? You've just learned the basics of putting your code on autopilot. So I'll leave you with this thought. What's that one boring, repetitive task in your own life that you'd automate first? Think about it.